Few words about the style of this class. We want to focus on basic ideas and concepts. There's going to be lots of formulas, but what we try to do in this class is to actually have you understand what those formulas mean. And in a year from now, when almost all of the formulas have been wiped out from your memory, you still have the basic concepts, you can understand them, so when you look things up again, they will still make sense. It's not a plug and chug kind of class where you're given a list of formulas, you're given numbers, and you plug in and you get answers. The really hard part is usually to choose which formulas you're going to use. You need judgment, you need intuition. Lots of probability problems, at least the interesting ones, often have lots of different solutions. Some are extremely long, some are extremely short. The extremely short ones usually involve some kind of deeper understanding of what's going on so that you can pick a shortcut and use it. And hopefully we're going to develop this skill during this class. Now, I could spend a lot of time in this lecture talking about why the subject is important. I'll keep it short because I think it's almost obvious. Anything that happens in life is uncertain. There's uncertainty anywhere, so whatever you try to do, you need to have some way of dealing or thinking about this uncertainty. And the way to do that in a systematic way is by using the models that are given to us by probability theory. So if you're an engineer and you're dealing with a communication system or signal processing, basically you're facing a fight against noise. Noise is random, is uncertain. How do you model it? How do you deal with it? If you're a manager, I guess you're dealing with customer demand, which is, of course, random, or you're dealing with the stock market, which is definitely random, or you play at the casino, which is again random, and so on. And the same goes for pretty much any other field that you can think of. But independent of which field you're coming from, the basic concepts and tools are really all the same. So you may see in bookstores that there are books, probability for scientists, probability for engineers, probability for social scientists, probability for astrologists. Well, what all those books have inside them is exactly the same models, the same equations, the same problems. They just make them somewhat different word problems. The basic concepts are just one and the same. And we'll take this as an excuse for not going too much into specific domain applications. We will have problems and examples that are motivated in some loose sense from real-world situations, but we're not really trying in this class to develop the skills for a specific, for domain-specific problems. Rather, we're going to try to stick to general understanding of the